Hello, everyone. My name is Florina Muntenescu. I'm a developer advocate at Google. At Google I/O earlier this year, we launched Architecture Components, a collection of libraries that help you design robust, testable, and maintainable apps. Since then, we've been discussed a lot with a lot of you. And then we saw a lot of questions that kept on repeating. Stuff like, OK, I'm already using RxJava in my application. Should I start using live data also? Or my architecture is implemented using MVP. Should I now move to MVVM? Or I need to display a large list in my application. What should I do? In today's talk, I want to tell you our suggestions of how to handle all of these. But before I go into this, I want to go a little bit over the architecture components just to make sure that we're all on the same page. And also, I want to mention a few of these do's and don'ts of the architecture components. So let's say that this is an activity that displays information about the user. One of the biggest problems for us Android developers is configuration change. So for example, when you rotate your device, the activity gets destroyed and then recreated. So to help with this, we introduced a lifecycle and the lifecycle owner. So an activity or a fragment has a lifecycle. Therefore, they are a lifecycle owner. And the lifecycle of a lifecycle owner can be observed by a lifecycle observer. And in that observer, we can define methods that will be called whenever specific lifecycle events will be triggered. So all you need to do is annotate those methods with onLifecycleEvent plus the event name that you're interested in. Architecture Components provides one such lifecycle-aware component, which is live data. Live data is a data holder, so it can hold information about the user, for example. And other components can set the value that is being held. And activities and fragments, so objects that have a lifecycle, can observe that live data. And then they can react on the changes of that live data. And then they can update the UI, for example. But when the activity is on pause or on destroy, the subscriber is removed. So the live data is considered inactive, and the events are not propagated. But once the activity is recreated, we subscribe again, and we can update the UI. The class designed to store and manage the UI data that survives configuration changes is the view model. So let's see how the lifecycle of the view model actually looks like compared to the activity lifecycle. We can see that we can create a view model only once the activity is created. And then the view model will only be destroyed when the activity is finished. So more precisely, the view model survives configuration changes, but it will not survive pressing back on your phone, killing the application from recents, or when the fragment kills your application. So this means that the view model is perfect for handling long-running operations, because the view model will be updated independent on whether the data is observed or not. So this means that you will no longer get these null pointer exceptions when trying to update a non-existing view. So make sure you avoid referencing views in view models, because they can lead to memory leaks or crashes. So the mindset here changes a little bit, because instead of pushing the data to the UI, you let the UI observe the changes. So just make sure you don't hold any UI logic in the view, but rather move this in the view model so it can be easily unit tested. So for example, it will be the view model's responsibility to get the user, prepare it to be displayed, and hold it for the UI. And then the UI will notify the view model of the user's actions. The view model would work with a repository. This will be a class that you define to get and set the data. So the repository modules are responsible for handling data operations. They provide clean API to the rest of the application. They know where to get the data, what APIs call to make when the data is updated. So you can see them as mediators between different data sources. So it's a good idea to have a data layer in your app completely unaware of the presentation layer, because algorithms that synchronize or keep caches or make database synchronizations are quite complicated. So you want to make sure that you add a single point of entry to your data. So this means that the repository will know which API to call to get the user from the network. And because we want to make sure that we don't request the data too many times, we're also going to save it locally in the database. But to save the data in the database, architecture components comes with a new library, Room. Room is a wrapper over SQLite database. It is an object mapping library that provides data persistence with minimal boilerplate code. So for example, let's say that this is our users table that has a user ID, which is the primary key, and a name, and all sorts of other information about the user. And what we want is actually every instance of that of the row should be an instance of a user object. So to do this, we define a user data model that we just annotate with entity. Here, we define the primary key and the column infos. To actually access the data in the database, we work with DAOs, so data access objects. We're annotating our class with DAO, and then we define access points. So we can define queries, inserts, update, and deletes. Queries can also return live data objects. So they're making this query an observable query. So what's an observable query? Let's say that we have this users table, and we want to get the users by ID. So let's say that we're interested in the user with ID 4. So live data will get the initial data from the database, which is the user with the name John. But then when we update the data in the table with, let's say, Mark instead of John, the live data will automatically emit that new information. So using observable queries means that we have a UI that observes, that reflects the latest changes in the databases, because the repository would expose a live data object, and then the view model will also expose a live data object for the UI. So what I've been mentioning before, or until now, with the view models and with the repositories is what we called a guide to app architecture. It provides testability and separations of concerns. But I saw that you've got a few questions about this. So, for example, how many live data objects should I expose from my view model? Should I have, so let's say that the live data contains a model for the screen. Should I expose only one? Should I expose multiple? So let's say that the top part contains some user information, and then the bottom part, some general settings data. So you can see that actually these are two different logical units. So what you could do is group together these logical units. So you could expose a live data for the user info, and then another live data for the settings. What if I'm using MVP? Should I switch to MVVM? So should you replace the presenter with the view model? Actually, it depends. It depends on the amount of logic that you have on how testable your classes are. The main idea is that you should keep the logic in the activities and in fragments to a minimum. So what you could do is put a view model between the presenter and the repository and still let the presenter work with the view. But what's extremely important is not to let view models and presenters know about the Android framework classes. And make sure you distribute responsibilities. Don't be afraid to create new classes. Should I use live data if I'm already using RxJava? If you're already using RxJava, chances are your project looks something like this. You're using it throughout the entire application. You're using it on the network part, on the database part. You have a repository that exposes flowables or observables, and view models that also do that. So one way you could do this is split the responsibility. Live data was made for the UI, so you could leverage that and let the live data handle the connection between the view model and your activities or fragments. You could use a composite disposable where you keep your subscriptions to the RxJava, and then in the view model on clear, you just clear those disposables. How about the data? How do we save it? Where do we save it? Should you save it in the database, in the view model? What should you save in on-save instance state? So before going over the few scenarios, let's look at this again. So only when the activity is finished, only then the view model is cleared. So let's remember this. So let's see what happens when the application starts. When the activity starts, you call onCreate, and in onCreate, we would actually get that reference to the view model. The view model will talk to the repository to get the user. So the repository would do a request to the network calling a getUser from your backend. The repository will save that user information in the database. And then it will expose that information to the view model. The view model will create the model for the UI, because maybe you don't want to expose all of that information that you have about your user, maybe only the first name and the last name. And then the activity will use that information and will display it. Let's see what happens when you do configuration changes. So, for example, when we're rotating the device. So on configuration change, the onStop is being called. But the view model still exists, still holds a reference to the UI model. When the application goes to foreground or it's recreated, the onStart is called, and then in our display method, we just get a reference from that UI model from the view model. That's it. We don't need to work with the repository at all. Let's say that our application goes to background, and then the user navigates back to the app. So in this case, when the activity goes to background, onSaved instance state is called. And then when the activity comes to foreground, we just display the user information based on whatever we have in the view model. Again, without requesting anything from the network. Scenario 3. Application goes to background, and then the process is killed. So in this case, when the activity goes to background, we should, in onSaved instance state, we should save the user ID. This is why. Because when the process is killed, the view model is also killed. So when the activity starts, in the onCreate, we would have in the bundle that user ID. So what we can do is just inform the view model about the user ID that we're interested in. And then the view model will just talk to the repository to get the user. But the repository already has that information in the database, so we no longer need to do another network request just to get the user. So the onSave instance state allows us to have the minimum amount of information that we need to restore our UI without doing any extra network requests. So what should you put in each of them? In the database, put the data that survives process death. In the view model, put the data that's needed by the UI. And then, in onSaved instance state, put the minimum information that is needed to restore the data. Instead of just a user, let's consider that we have a list of users. Many applications need to load a lot of information from the database. Database queries can take a long time to run and use a lot of memory. And we have a new paging library that we will release soon that can help you with all of this. So the main components of the paging library are a page list adapter that actually extends the recycler view adapter, a page list, and a data source. The data source is an interface for page sources to provide data gradually. But you will need to implement one of the two data sources, either a keyed data source, which will be used when you need to load item n based on the item n-1, or a tiled data source that allows you to jump in any place of your data set instantly. And you'll also need to implement another method, load count. This one will be the one that tells whether you have an infinite or a finite amount of items that you need to display in your list. The page list is a component that loads the data automatically and can provide update signals to, for example, to the recycler view adapter. The data is loaded automatically from a data source on the background thread, but then it's consumed on the main thread. And it supports both an infinite scrolling list, but also countable lists. And you can configure several things. You can configure the initial load size, the page size, but also the prefetch distance. So here's the data flow. Let's say that we have some data that we put on the data source on the background thread. The data source invalidates the page list and updates its value. And then, on the main thread, the page list notifies its observers of the new value. So now, the page list adapter knows about the new value. So on the background thread, the page list adapter needs to compute what changed, what's the difference. And then, back on the UI thread, the view is updated in the onBind view holder. So all of this happens automatically. You just insert an item in the database, and then you see it animated in, and no UI code is required. OK, let's look at the code a bit. So to tell the page list adapter how to compute the differences between the two elements, you'll need to implement a new class, diff callback. Here, you will define two things. You will define how to compute whether the contents are the same, and how to define whether the items are the same. To simplify the connection between the data source and the recycler view, we can use a live paged list provider. So this will expose, actually, a live data of a paged list of our user. So all you will need to do is provide a data source. But if that data source is true, then it will be generated for you in the DAO. You don't need to write any invalidating handling code. You can simply bind the live data of a page list to a page list adapter and get updates, invalidates, and lifecycle cleanup with a single line of binding code. So in our user DAO, we would return a live page list provider of our users to get the users by the last name. And then, in the view model, we would extend from the architecture component view model. And then we would keep a reference to that live data of a page list. And we will get that reference from the DAO by calling getUsers by the last name. And then calling create using the configuration that you want. So for example, setting the page size to 50, setting the prefetch distance to 50, and so on. In our activity, the activity needs to be, of course, a lifecycle owner. And then, in the onCreate, we get a reference to our view model. We get a reference to the recycler view, and we create our adapter. And then we use another handy class from the architecture components, live list adapter util. So this provides hooks for live data and lifecycle, so you can bind with just one line of code and not worry about the cleanup. And then we're just setting the adapter to the recycler view. Let's look at the adapter. So our adapter would extend page list adapter, and then it will connect the user, which is the information that we need to display, with the user view holder. And then we define the callback, the diff callback, for our user objects. And then in onBind view holder, all we need to do is bind the item to the view holder. That's all. We have a lot of new concepts and components with architecture components. But the thing is, you can use them separately. So if you want, you'll only be able to use lifecycle, live data, and page list. or only view model, or only room, but you can also use them together. So start using the architecture components to create a more testable architecture for your application. Thank you.